So hi everybody, good morning, good afternoon, good evening, everybody who's joined in. So today's webinar is on the topic offline sync, as you all know. My name is Tanmay and I'm the community manager at Kony. And today's webinar demonstrates how to easily enable an application to work offline by synchronizing data to the device. Your host and expert for this session is Suhas Bhat. He is the Senior Director of Kony Product Management at Kony. Before we start the session, let me share a few things that you have to put your questions in the Q&A panel and not in the chat box. We have experts monitoring Q&A panel, so you can put your questions there and we can answer them. We are also recording this webinar and we'll post it after this session. The articles, you can go to Basecamp article section and then you will see the webinar recording there, so you can just read it, listen to it later. We are also running a couple of polls during the event, so you can participate in these polls and weigh in your answers. So let's start the presentation. Over to you, Suhas.
Thanks, Tanmay. All right. So we'll be looking at offline objects in this session. Offline objects is basically the new way that Kony has tried to solve the synchronization problem for apps to work offline. So let me start with an overview. So why should apps have offline access, right? So most of the apps that we have today, are working only online, but not always. You'll not have network all the time. You'll go into a tunnel, you'll lose connectivity, and online apps typically tend to hog a lot more data, right? You have to download the same thing again and again if you've not seen through it, and whenever you're sending any changes that you're doing from your client app, you end up sending the whole payload over and over. So Hey,
Suhas, are you sharing your screen? And we're not seeing it, so if you could reconnect. Thank you.
Yeah, we can see your screen now. Yeah.
Okay. So yeah.
Thank
yeah, and data is not used in an optimal fashion in online apps, right? And with the advent of PW and other things, you see that there are a lot more companies that try to have an app that works in an offline mode itself, right? So that even if you're looking at everyday apps like news or just your Twitter feed or stuff like that, if it is stored offline, you can always go and visit and read stuff that was there, that is in your system, and not have to be online or not always have to pull the data from the network, right? So in general, who has been using offline kind of apps, right? So the most basic case that people use are field agents who have to be traveling, or probably in a rig or traveling a lot, and they can't always have access to online data. So those kind of people have been using traditionally, but we see that more and more enterprise employees also start using offline kind of apps because the data is available offline, and why not you, right? So we're just trying to see who all it makes sense to, and so we believe that as we progress, we'll have more and more apps which will have offline capability and be able to work seamlessly online as well as offline, and that is the direction that we are trying to go here. So let's start with what an offline app looks like, right? So we have several vendors who provide a synchronization capability. So the basic sync just takes care of syncing like a JSON text and just converting the JSON to an object, and then synchronizing it, doing some basic conflict resolution, and then sending the data back to the backend. So that is what our web services are connected. So it is what a basic synchronization capability does, right? So in what an advanced synchronization capability will do is, it will have an relational object model, right? You're not dealing in terms of just text, you're dealing everything in terms of models. You'll have the ability to specify filters and say exactly what data you want and what to send. In case there is an issue, you will want to be able to roll back to what was the last synchronized state. You should be able to batch the data, right? Not send everything in one shot, group it, send it so that the network performance is optimal, and even if you have to roll back or stuff, you can pause and stuff at the batch level. It will have a context of what is the transaction, right? I'm sending this, so this was what has changed since the last time I synchronized. I know exactly what changed. I maintain a history of the data in my database, in my local thing. So I have full context awareness at all times, right? And if there are unrelated objects, it should be able to run synchronization in parallel across all these different objects. So these are all the capabilities that an advanced synchronization system should have, right? So Kony has all these capabilities, and we deal with complex objects, and we have ability to synchronize relational data, and we can connect with a host of web services and connectors, right? So this is just to give a picture of Kony Fabric. I'm not sure how many of you are already existing customers, so I just wanted to just still briefly explain how the Kony Fabric is and what are the components and how it works. So Fabric is basically for connecting your client application to the backend system of truth, right? It has a host of features, and just basically starting with the integration services, which is just connecting your client app to the server, and then building on top of it with an orchestration service which can group or call multiple integration services. We also have an API management layer where we expose these APIs that we are defining for consumption by end users outside of a client application. So if you just want to expose those APIs to another vendor or another partner of yourself, and you want to give like different versions, you can have an API portal and you can expose that data to them, right? So they can just hit it and get the data just like any weather underground or all these Google APIs that they expose, right? So we have all these capabilities, and we have inbuilt analytics for all of the features of Kony. So we get data right from the client application from the time, say, somebody uses a form or makes a network call or touches a button. All the data is gathered, sent from the client app, goes to the Fabric, right? Then we process it and have a standard out-of-the-box reports for customers to build, to view the performance of their app, or how a user is using the app, or if there is an app crash or something, when it crashed, what the user was doing when it crashed, what was the CPU, what was the storage, all these kind of data is gathered from the application, and we give some out-of-the-box reports. And if you need more customization, we also have capability of custom reporting and such for the analytics perspective. And we also have application management. We have our own enterprise app store where you can deploy apps, and you can use it for either hosting enterprise apps within the company, or even for very simple things like you want to just test a binary that you are building, and having an enterprise store gives the easy way of deploying the app and making it available for the QA folks who want to test it and then be able to upgrade it and maintain it. Makes it a lot more easier and seamless because it is integrated with the Kony Fabric itself. And we also have built-in security, we have built-in encryption, right? We have single sign-on capabilities, auditing, and we have operational consoles where you can see the performance of the app and all that in real time. So this is just to give an overview. And what we have also added in Fabric is called as object services. So object services is basically like taking your mobile backend as a service to the next generation microservices. So in a mobile backend as a service, you are writing low-level services and you're writing your code to automate build and stuff. But in an object world, you are defining everything in terms of an app data model, right? Then you can map and transform the backend data into the app data model. You can group the related content. You can reuse these objects. So it gives you a lot more flexibility when you are using an object service. Your client app is only interacting with the model that you have defined. How the model actually connects to the external world can be changed at any time. So basically, you could be writing just a service that is pointing to a database when you're defining your application. But once you have defined, you might be connecting it to a live REST service or even a database or some other medium for it to get the data, or an SAP system, for example. So you can keep switching out your server side and backend without the client code having a single line of change, because the client is only interacting with the model. So that gives you flexibility and an abstraction which the earlier versions do not have, right? So we are going towards the object model and object services for higher productivity and greater flexibility. So how does object service work, right? So with this diagram, we are trying to explain, like, you have a client app which is dealing only in terms of say a sales or a field service app. So we have defined a work order model, right? This is the client app model. It has data in terms of, say, an order or an address or tasks or materials, basically objects that the client app has to interact with. When you look at the actual backend app, it will have a lot more points, and you can map this object to a specific object, or you can map it as a group of multiple objects that you're mapping to the same thing. Or if there is some field that is not there in your backend but you want to introduce it, you have the flexibility of adding that as well, and same thing. So this mapping gives you the ability to this is the only layer that you have to change if you are changing your backend to a different thing or switching it to one environment in dev versus another for production and all that. So this mapping gives you the flexibility of using it, and you can that after from the backend object could be interacting with the system of truth like an SAP or a legacy database or Salesforce or anything via either an integration service or an orchestration service, or directly via object services or using offline objects or otherwise, right? So this separation and flexibility is given by object services. And if you are using object services, we also have the ability of automatically generating the data model on the client app, so that you already have built-in APIs for interacting with the fields, for example, setters and getters for all the fields that are there in the work order app. For example, if there is an order object, if it has multiple fields, all those fields you can generate an automatic data model in the client app to use it. So the reason I'm explaining all this about object service is offline object is built on top of object service. So object service is a prerequisite for using offline objects. So as I explained, object service is model-driven app design. So it follows a microservices architecture. You can inject it into any app, right? You can define your preferred data model. There is a clear separation and abstraction, and you can connect it to either LOB, line of business things like SAP or Salesforce, or you can even have, say, traditionally companies just use the integration service because that is what has been there for a much longer time. So if you want to just reuse an integration service and put a object model on top of it, you can do that as well with what we call as a service-driven object. So service-driven object is created from a set of existing integration services, and it connects to the existing API, and it could be an integration service or an orchestration service. You can combine multiple APIs, right? You can create a complex composite from them, and you can still reuse that using object service. So the object services layer that I explained is same for online as well as offline. So the server portion of it is same. So that gives us flexibility that you can, we do not need a separate runtime because we are reusing existing components of Kony Fabric. But the client code, because we have to actually store the data in the database, right, on the client app, we have to have a different logical structure for offline. So the way we have done this for offline objects is basically on the client app, we have written the entire synchronization logic in native code. So we have native APIs written for iOS and Android. We are working on Windows 10 and SPA. It will come out sometime in the future, but currently iOS and Android are GA. So we have written native APIs, and that synchronizes directly with the runtime and through the OS. And we have exposed JavaScript APIs so that you can reuse this functionality from your client applications, right? So this flexibility gives us it gives us much higher performance because there is the JavaScript is only an API interface for invoking functionality, and all the functionality happens in the raw native database and native APIs. So coming to offline objects. So this is, as I said, it's a new type of synchronization capability that we are supporting from the V8 version of Kony Fabric. So V8 was launched like 6-7 months ago, and it is using the existing Kony Fabric runtime server. No additional runtime required. If you're an existing customer using Kony Sync, you'll know that it will have a separate runtime for it. So Kony offline objects is built to avoid that and run on existing hardware, and it downloads the data that you are on the device in a SQLite for offline access. And we are using an OData protocol, which is a standard protocol for querying data, and we are trying to follow the same OData protocol on both the client as well as server, so that we have standard mechanisms of querying your server data or as well as your client app for getting any data, right? So we can currently support apps built with Kony Visualizer for iOS and Android, or you can build an app natively using just the Kony iOS SDK for Xcode or the Kony Android SDK for if you're building an app directly from Android Studio. So we support both native as well as Kony Visualizer built apps, right? And we also have what is called as tracking sync progress, right? So synchronization, depending on how much data you are actually synchronizing, could take considerable amount of time, right? So some people have even a gigabyte of data they are synchronizing for the first time, for the initial sync especially, right? So knowing how much data is synchronized, how much data is pending, right? That is very, very helpful. So that sync progress is another thing that we have added into this. So it gives you progress on a batch by batch state. It will tell you exactly how many records are uploaded, exactly how many records are downloaded in each batch. And you can see it in real time if you want to see that kind of progress, or if it is too verbose, you can register any API to see at the end of a synchronization process how many records are uploaded, how many records are downloaded, and those kind of stuff. So you have basically the stats as well as the progress in real time, right? And it also has the ability to run parallel sync. So you can run parallel sync only if the objects that you are synchronizing are not related, because obviously if I'm doing a related object, then I can't run them in two different threads and introduce conflicts into the database. So if you're having completely different things like a work order and sales thing, right? Two different object services that are both required for the application, but they're having unrelated objects, then I can run them in parallel and synchronize them at the same time. And both will run on different threads, and it will not affect your application performance, right? So now let's start looking at object service offline object features as to what all we have, right? So core features for any offline synchronization capability is the ability to download and upload all the objects in an object service, right? So if you had, for example, in our work order case, we had, give me a minute. So we had 4 objects in the CRM, or 4 objects in the work order, say order, address, tasks, material. So a typical object service, you will be able to synchronize for the object service work order itself. It will be able to synchronize the data for all of them in one shot, right? So now that feature is definitely available. We also have APIs for performing CRUD operations, your create, read, update, and delete operations on all the objects on the client side. You have the ability to always reset the data that is there on your client side. So basically, as I said, we store all the data in a SQLite database. So you can reset it to its initial state, empty it, and all that functionality is available. And as I said, we also have support for iOS and Android native. So that is what a basic synchronization user would need. We also have some advanced features, like we basically can set API to filter the data that is being synchronized. So for example, for a work order, you have data for all the technicians in your database. But when a particular user is signing in, you want to synchronize only data for that technician onto the device, not everybody's. So you can set filters on what you want. So you might want to filter it only for a specific object for that technician, but generic other data like locations and stuff, you might want to synchronize for everybody. So you have that capability of setting filter and synchronizing data only for specific things using the filters, right? And we saw in the previous state that it was synchronizing all the objects for the object service. We also allow granularity to synchronize only specific objects if you want, right? So for example, back to the work order, I want to somebody's address changed, nothing else changed. I don't want to synchronize the whole thing. I want to just synchronize this, or maybe my tasks, because my task is what keeps changing usually. Other things are pretty constant, right? So I want to only synchronize tasks, not everything in my object service. So that granularity is also available. So you can only synchronize a specific object if you want in an object service. And say you ran into some error during the synchronization, you had some inconsistent state, whatever, you want to roll back to whatever was the last state. That ability is also there. You can always roll back to the last successful synchronization state. We also have support for data reconciliation and batching. So as I said, if the data is being downloaded is considerable, you can specify batch sizes and download the data in batches. You can also do upload of the data also in batches. And we also support encrypting the database that is there. So the SQLite whole database, you can encrypt it using just an API. And we also have support for policies, like I am working on something. I just want to push my changes but not get the latest changes. Then I can say, okay, I just wanted to upload only. Or say I'm still working on something, I don't want to upload my changes yet, but I just want to know what is happening on the system, so I want to download only. So you can do that, right? Or you can, okay. So sync also has, by default, we track each and every action that the user did that affects the database. So for example, you created a record and then you updated it once, you updated it again, it will keep in what we call as a history table, 3 different items. So one was the create, and then an update, and then another update. And when we try to play it back to the server, we play it in the exact same sequence that happened, right? So we'll do a create and then an update and update. But say customer is not interested in replaying all of them. He just says, so just put the last sync state, right? So I might have done update 3 times for the same object, but I'm not interested in doing 3 different operations on the server. Just sync my last state. So that option is also available. You can turn off change replay and say, I just want to sync last state. That is doable. And say you're working on a work order on one particular item in your database, right? You're working on one specific work order, and the other things you are okay with uploading and downloading and stuff. But this one you want to say, don't upload it. It is still incomplete. So you can mark that as false for upload. So that way, when we are synchronizing the data, we'll see, okay, this one he doesn't want to sync it. We'll skip this. Everything else we'll synchronize, right? So that level of control also you have when you're using offline objects. And we also understand hierarchy within the objects, right? So you have to, of course, define it when you're defining the object service. But once you have defined the relationship, we know the hierarchy between objects. So which is a parent, this is a child, and this is the child's child, right? So when you do a delete of the parent, the child will become an orphan. So we have the option of doing a cascade delete, so that when you delete some parent, the children are also deleted, so that you don't end up with orphan objects in your client application. So that feature is also available as part of offline objects. And let's look at, all this is fine. What is differentiating Kony's synchronization capability from others, right? So as I said, download and upload for a single object is something that level of granularity is something specific. And we also have, as I said, because we're running it completely native, you can run it just as a background process. It doesn't have to block the UI, it doesn't have to interfere. So you can just run it as a process in the backend and get the synchronization done. And because, as I said, if it is unrelated object, you can run them in parallel, and you can run them in the background. And we have also introduced something called as logger SDK in Kony from V8, and that is something that is inbuilt into the offline objects capability as well. So logging will improve the ability to troubleshoot an issue, and you can even collect client logs directly from changing a setting on the server. So all this is part of the logger SDK capability, and we have integrated that logger SDK into offline objects to make troubleshooting much easier. And as I said, we have APIs for tracking sync progress and seeing the state. We have APIs to pause and resume a sync, right? And another feature that we have is called as upload cache. So basically, where this feature is useful is I am synchronizing a data from my client app to the server, but before my server, as in Kony server, returns with the success for it, because the client connects to the Kony server connects to the backend, right? So before the data comes back, there is some network issue with your client app, so it could not get a success. So as far as the client app is concerned, it did not succeed. So the next time it tries to sync, it will try to resend this data, but your backend has already received it and created a record. So this should not end up creating a duplicate. So different backends behave differently. If the backend is resistant to these kind of loops, then you don't have to use this feature. But if the backend is not resistant to these kind of loops, then you can use this upload cache feature. So it's an optional thing. So what we do is basically every single payload that we send from the client app, we store with a specific request ID or stuff in the client app, and only after we have got a confirmation that it is good, we go and delete it. Else we'll maintain it for a while, so that we, if the same data comes again to the server will have logic to check, okay, this has been sent earlier, so I'll just send a response back to the client saying this is in progress or something, and not go and push to the client, to the customer's backend this data. So that logic and intelligence is built into the upload cache. And another very useful and very powerful feature that offline object has is it can absorb incremental change without requiring client binary update. So you are having a backend app, right? They added a new field to an existing object. So you do not have to go and change your client app to get the data, right? While you are initializing app, you have an option of saying support incremental setup, right? So once you do that, any such minor changes, it can absorb few changes, not everything. Actually, it can absorb most of the changes, logical changes, like you added a new field, or you removed an existing field in an existing object. It can absorb that and synchronize it automatically. If you add a new object or deleted an existing object in an object service, it can automatically handle that, and it can download that. What it cannot handle is logically, like, you have to have a primary key for every object. If you change that primary key, no system will be able to handle it. So those kind of scenarios we cannot support. But anything like an add delete operation for an object or a field, we can handle that easily without any client change. So it will synchronize the data for the new field and all that, it will take care. Of course, if you want to show that field in your client app, you still need client app code changes, but the data synchronization can happen automatically using just the incremental changes feature. So now that we have talked about what offline objects is and what all it can do, okay, so the question is, okay, how do I make an app into offline app, right? I have an existing app, how do I make it into an offline app? So as we said, the prerequisite is app has to be using object service. If it is not using object service, you can convert it, your integration service, into an SDO, and that way make it into an object service and use it. And every object that you're trying to sync has to have a primary key, because we need to be able to uniquely identify that. So that object model should have a primary key. So these are prerequisites. Once that is there, what you go and do is you basically go to the server, and the object service, you'll offline enable it. And because we have to maintain context, right? We don't want to synchronize everything all the time. We need to know what was synchronized last time, so that we only synchronize the delta, right? So for that, for change tracking, we need a flag. So basically a timestamp or something, you set a flag and say this is the timestamp field that I have to look at, and that it knows, okay, I have to see that for my change tracking and stuff. And if there is a delete, right, a soft delete, like you deleted and you want to know what is the flag to know that it is deleted, soft delete flag, that also has to be set. And once the change tracking is set and the offline enabled object service enabled, you have to publish the service definition to the target server with the update, right? And from the client side, we support both object models generated using the Kony MVC reference architecture, as well as even if you're not using it, we still support it. So both models, with and without object models, generated object models, is supported by offline objects. So generating object model in this case is an optional step. Okay, and of course you have to initialize offline objects. So initialize, what it does is basically it creates the database structure on the client app. It creates the table schemas and all that and sets it up. And then we need a user action to synchronize data. So basically the regular online app will not have just a button for synchronize, right? So it will be trying to make an online call at every submit, for example. But in this, because we are trying to optimize and all that, you'll have to have somewhere a sync button. Whether you have it as a button or you run it as a background process is up to the app developer, but you need to define a function for doing the synchronizing. And in case you are using, object models or otherwise, it has a param which says online, which you need to change to offline in case you are using offline objects. So that is pretty much the change that you have to do to convert an existing online app that is using object service to an offline app. Now let's go through a demo of how you go ahead with this, right? So for this, what I'm doing is I'm taking an app called as work order, okay, which is existing today in marketplace. So this is the Kony community marketplace. You can just download this app from here. It's a work order management app. So the app, what it does is it has two components. It has a server desktop web component and a client component for mobile app. So basically a supervisor, for example, logs into the desktop web, creates a work order, and then assigns it to a particular technician. And then the technician gets the work order from the client app, and then he uses it, right? So that is the basic case of this app, and it is online, and I'm going to show how to make it into offline. So we'll start with this particular screen, which is the object screen, object services screen for this particular app, right? So this WOM objects, work order management objects, is basically the object service. So the object service has all the objects, and you can look at all the fields in the object service, and what is the parameters and values, and you can also have relationships if there are relationships between them that defined, right? So all this is present in an existing object service itself. So this screen is the object service definition itself. So this is where you define what backend it connects to and what is the authentication level and such. So here we have this checkbox for offline enabling this object service. So once you do that, we do some metadata changes so that the client app knows it is offline enabled. And once an offline enabled is selected, you have further options that comes up to determine the conflict resolution policy. So basically the conflict resolution determines what happens when a client app has a conflict. So you can determine, say that client wins, which means whatever code is in the client will be applied to the server. and the server is getting overridden basically. And the server means whatever the server's changes gets applied to the client. So client changes gets overridden only for the conflicted cases, right? Or you can also set it as none if you don't expect this. So what none does is it doesn't even check for conflicts. It just synchronizes. This will be a slightly faster, but most customers would probably want to set one of the conflict resolution policies. And we also have this optional ability to enable upload cache, which I already explained. So this is basically to cache the payloads in the client in the server side for like 24 hours to see if the same data is sent again because of whatever network failure and stuff. It persists it and it can tell back to the client that this is in progress or whatever state to avoid dupes on the server, right? So once you have done that offline enablement for this particular thing, you save that object service, and then you go to the saving it, and then you open and set the change tracking that I explained. So here we are setting the timestamp for the delta context, and we also are setting the soft delete flag for identifying soft deletes. So now the client app, the server, when it is synchronizing, it knows what is the delta context, what field to look at in the object service to identify the delta context. So after this change again, we are saving it. So once the changes are saved, you just choose the server that you want to publish to, and then publish the updated service definition. So once it is published, we go to the client app and we link it to that work order management app that we just updated. We choose it and associate it. We can see the changes that we have done already reflecting here. So we'll go and generate the object model. So what this model, generate object model, does is it connects to the server and gets the metadata for all the object services, and it knows what are all the objects, and it creates that object structure here with the getters and setters for all the fields that are there in that particular object service, right? So we'll go and look at a specific model for work order thing. So you can see all the created by all the fields that are there, right? Last update time, status, and all that. It has the getters and setters, any relations that are there. It will have all that defined, and it gives you the APIs to interact with that model in the client app. So now once that is done, we told that we have to first step initialize the setup. So we go to the pre-show of the first form. So the first form was the login form. So if you just missed it, so we go there and we set up the invoke function. So we basically are setting up a function which is going to initialize, right? So it basically just boils down to this one line of code, which is Kony Fabric offline object setup. So you have to have a success and failure callbacks, and we're also activating the logger for the app at this place and setting some log levels. So these are all options. So once you have defined that, your object schema is created during the app launch itself. So the next stage, as I said, is you have to go and set up a function for sync. So in this case, I added a button here in the home page of the application, and on clicking it, I'm going to set up a sync function. So this is the sync function where we are calling the start sync, and I've also specified batch size for the download as well as upload, and I'm doing whatever business logic changes that I had to do for this. So for example, basically showing something as at that point after the sync is done and stuff. So any other business logic you want to add for that particular thing, you can add it. But the basic thing which does the sync is this, just a start sync with options. Options supports a lot of things. In this case, we are showing upload and download sites. The sync config policies and other stuff that I discussed earlier will also be in the options, right? And then you set your success and failure callbacks similar to what we did for the setup. Another callback that you can set up for sync actual synchronization is this progress. So this progress is what I had told you, right? It gives you the progress as it is happening in terms of batches, like how many records are uploaded, how many records are downloaded. So now you can hook that logic. You'll get the data back into your callback. So how you show it in the UI is up to the app developer. If you just put it into a an alert box, it will just show all the data that's coming as is in the alert box. Or in this particular application, I'll show you, and we have added it as a not as a per batch, but at the end of the sync, we are showing how many records are uploaded or downloaded by just putting a widget in the top of the home page, right? So once we define that, we go and start changing the models to use offline. So here, this is an existing function that is already present in the application, which is getting the technician's ID, right? So it is going through the object model and doing a get all, and it is having this access variable as online because it is trying to get it from online. But now we have changed the object service to be offline. You can modify this from online to offline, and it will know that it has to get the data from the database and not make a call. So similarly, this is another object where again I have to go and change it from the access to online to offline. So I have to change all the places where it is trying to access online to offline. So that's it. We are done with the changes for making this app into offline, and we just build it to whatever target app, and in this case it's an Android app that I've built. So I did not show you the desktop web code because the desktop code was already online, and I'm still keeping it online because the supervisor is not going around. He's accessing it from a desktop and creating the object, creating the order. So that is still continuing to be an online app, whereas the mobile app is now offline. So the user logs into the desktop app using his Kony credentials. Then he sees the list of work orders, and he goes and creates a new work order, right? So for this case, I'm taking the case of he's a wind turbine technician. They are going around walking and seeing what has a problem. So somebody saw that something has a issue, it caught fire and it needs to be addressed. So they are creating a priority work order and they are setting it. And you also have the ability to add binaries. So see, offline object supports binary download. Upload, you'll have to do it using online APIs, but the solution end-to-end is available, and we'll be showing both upload and download as part of this video as well. So he chooses an image from the client, from the desktop, and he sets it, right? And once he creates the work order, he has to go and assign a technician that has to work on this work order. So he chooses the list of technician, he goes and assigns it to a particular technician, in this case somebody called as Mr. Murphy. So he has now created the work order and assigned it to a particular technician. Now we go to the client app where the user, the technician Jason, is logging into the app, and once he logs in, he sees the existing work orders that he has already finished, and it depends on the client app what logic, but you can do a synchronization and get the list of new stuff that he has to work on. So as you see here, once the progress, this sync progress wave based on the sync status sync progress callback that I showed you earlier, and once it is synchronized, we show how many records are uploaded and how many records are downloaded. So in this case, it is saying this many records were downloaded, and there was nothing to upload because I just logged into the app, right? So we did that, and he goes and sees the particular work order that was assigned to him, and you can see the description and the image that was uploaded from there, and he accepts that particular work order by clicking on accept. So once that is there, it comes as in progress. He spent a couple of days, so I'm not sure if you noticed the other thing was assigned on 12th May, and now he has come and he is working on it, he's finished it. So once he has finished working on it, he is uploading an image of the work, as it is being set back to normal, right? So he just says this is done, and he marks that particular work as done, mark complete, right? And once that is done, the supervisor who is on the other end on the desktop web, of course, he has to synchronize the changes. This is not an online app, so he has to synchronize whatever he has done. So this way, if he's working on multiple work orders, at the end of the day, if he wants to just sync, it will sync and push all the changes that is there on the client app to the server. So in this case, you saw that it was uploading for. The previous one, if you saw, it was downloading for. It is basically the number of objects. So it is uploading that many records, right? And it downloaded something else, right? And so now it is done and synchronized to the backend. And the supervisor on the desktop app, he can see that that particular task is complete. So this is walking through an app of how you convert an online app to offline, right? So, yep. So that's pretty much about this. So for more info, we have a API reference guide as well as a getting started guide. So let me just briefly go through this. So the API guide will have all the APIs we talked about: the setup, drop, reset, rollback. You have an object service APIs like start, sync, rollback, or an object level API like the CRUD APIs and deleting data. Deleting by primary key and such. We also have a getting started guide. So So the getting started guide is basically to help you understand offline objects and get started with it if you're a fresh user. It talks about many of the features that I spoke to you in the session today about how to use this, how to use that, how to set up hierarchy, how to and it also has a couple of sample apps that are already built in. So there is a sample app section in the technical overview. You have a sample app which is pointing to SAP as well as another sample app which is pointing to a database. So it has the code for both the client visualizer app as well as the server side Fabric app. You can just download them and start using them, right? And it gives you step-by-step instructions on how to go about doing it for each of the apps, exactly point 1 to point 20 or whatever. It goes in great detail and explains you how to go about doing this, right? And we also have a couple of articles in Basecamp about offline objects. So this one in particular gives you an introduction of offline objects and how to use it and what it is used for and stuff. So these all should get you start. The specific sample app that I have showed you in this, we'll get that published also shortly to Marketplace so that you can have both the online as well as the offline version of the apps in Marketplace. So that's it from my side. Thank you. Are there any open questions that I can answer?
Thank you, Suhas. Thank you for this session. It was really great. Yes, we do have few questions. We have answered almost all questions. I think one or two questions are left. Do you want me to read it out for you, or can you see the panel?
Just give me a minute. I'll try
Okay.
to see the panel.
Or if you want me to read it out, that's fine. I can read for you. The first question says, I saw Kony Fabric listing Enterprise App Store as a feature. Is that through the Kony EMM product?
Yes, we used to have a full-fledged EMM product, but we are ramping down on that. But the Enterprise App Store is available directly from the community edition of Kony as well, from V8 SP2. That is the latest launch that we did. It was part of the EMM earlier, but right now it is available for everybody from the community itself.
Okay. So the second question is, can you please explain when it comes to user management through Kony Fabric?
User management through Kony Fabric. I'm not sure that is really relevant to offline objects. I'll probably have someone respond to that offline.
Okay. All right, no problem. Anyways, we are going to, put the entire Q&A in the article. So please have a look, Janardhan. That's your question. So please have a look at that article. We will definitely post answer to your question, and then you can later, have your answer. So there is one more. Just let me have a look. And yeah, so this one is also from the same person. He says, Fabric user management, it's visible for other team members, accessible from same team who has creational. I don't think it's a complete question, but can you answer, Suhas?
No, that is also not related to offline
Okay.
objects. Yeah.
Okay, so I think all questions we've already answered, so we don't have any more questions. So everybody, if you have any questions so far, we are still here for a couple more minutes. You can post your questions, and we'll be happy to answer. And for your information, we have our next webinar on June 13th. That will be on V8 SP2 features. So you can also check all the events that we are doing. You can go to Basecamp homepage and click on Events tab and see all the events that we do, and subscribe, register for all the webinars that we have posted there, and get be part of it. If you have any questions, feel free to post your questions in Basecamp forum. We have experts answering those, so that is also there. So I don't see any more questions here. So thank you everybody for taking out time, and thank you, Suhas, for this wonderful session. I'm very sure the session was helpful to everyone who has joined here. And thanks everybody for joining this session. As I said, we are going to post this recording on Basecamp so that you can listen to it later. You can even share it with your friends, peers, if you want, and feel free to post your questions on Basecamp. Thank you so much, everybody.